Okay, welcome to Miss Sussman's class. Please make sure you have a pencil and paper ready to take notes. Also, you're going to want to review prime numbers and your divisibility rules before we proceed with this lesson, because you need, especially prime numbers, you need to understand what a prime number is before you get started with this. So just take a couple of seconds and look over your notes from when we talked about prime numbers, just to make sure. And I'll do a quick review as well. Remember, a prime number is a number that only has two factors, one and itself. And a factor is any two numbers that can be multiplied together to equal that number. For example, this number 48 has several factors. It's 1 and 48. I know 2 is going to be a factor because I looked at the last digit. I'm using my divisibility rules. The last digit's even, so it's going to be 2 and 24. If I add 4 plus 8, I get 12, so that means that 3 is also going to be a factor, so 3 and 16. 4 is also going to be a factor. It's going to be 4 and 12. See, 48's got a lot of factors. And these are just factors, okay? 4 and 12. 5 is not going to be a factor. 6 is going to be a factor because it was divisible by 2 and by 3. And so 6 and 8. And that's all of the factors of 48. So that's factors. But now we're going to talk about prime factors. And prime factors are a little bit different. So I'm going to erase this. Prime factors are when we take a number and we break it down into only its prime numbers. Okay? And I'm going to show you, there's two ways you can do it. You can do a factor tree or you can do a ladder. And I'll show you both of those. Let's do a factor tree first. Okay, so with a factor tree, what I do is I take two factors of 48. I'm going to do 6 times 8. Okay, 6 and 8 are not prime numbers, so I have to keep breaking down these factors until I get to a prime number. I'm going to start with 6. I know that 2 times 3 is 6, and I also know that 2 and 3 are both prime numbers. Okay, so I have broken them down, the number 6 down into its prime factors, because I can't break 2 and 3 down into any more factors because they're prime numbers. Okay, let's do 8. I'm going to do 4 times 2. 2 is a prime number, so it's broken down, but 4 is not. I can break down 4 into 2 times 2. Okay, so now I'm left with only prime numbers. I can't break down 2, 3, 2, 2, and 2 anymore because they are prime numbers. So the prime factorization of 48 would look like this. 2 times 3 times 2 times 2 times 2. And that comes from these numbers right here. And if you multiply 2 times 3 times 2 times 2 times 2, you will get 48, because 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24, and 24 times 2 is 48. Okay, so the prime factorization for 48 is 2 times 3 times 2 times 2 times 2. Okay? So that's one way to do prime factorization. We're going to look at another way in the next slide. Okay, the other way to do it is using a ladder diagram. And I'll show you what that looks like. Basically, I'm going to take 48 and I'm going to keep dividing it by only prime numbers. 2s and 3s are usually a pretty good choice. And in this particular case, I could use either one. But I'm going to start with 2 because that's an easy one for me. And I know that 48 divided by 2 equals 24. So 24 is going to go down there. And then I'm going to take 24 and divide it by a prime number. I'm going to use 2 again. That's pretty easy. And I know that 24 divided by 2 is 12, so I put my answer here. And then see how it kind of looks like a ladder? I'm going to do 2 again, and I get 6. And then I'm going to do 2 again, and I get 3. And then 3 divided by 3 is 1. Once you get to where 1 is your final quotient, you're done. And then if you'll look, you'll notice that the factors we have are 2 times 2 times 2 times 2 times 3, which was exactly the same as when we did the ladder or the tree, the prime factorization tree. You can do either one, and I'm going to work both for you. I'm going to work a couple more examples so you can see what it looks like. It's really just whatever is comfortable for you. If you're not as comfortable with your math facts, using a ladder diagram may work for you because you're picking the prime numbers that you are dividing by. If you're super comfortable with your math facts, the ladder tree the tree may work a little better for you because you know, because you're just breaking it down into math facts until you get to prime numbers. So whichever one you like. Like I said, I'll work both for you so you can see what they look like. Okay, let's try another example. Okay, you'll notice I have the number 54 written twice. I'm going to work it as a prime factorization tree and a ladder diagram so you can see what each one looks like. Okay, I know my math facts, and I know that 6 times 9 is 54. So I'm going to start there. And then this one's easy. 3 times 3. I'm done. I can't break down these 3's into any more factors because they're prime numbers. Okay, and then 2 and 3. And the way you check is by multiplying your prime factors to see if you get the numbers. So 3 times 3 is 9. 9 times 3 is 27, and 27 times 2 is 54. So these are the prime factors, and they're all prime numbers. That's the other check. So you multiply them together to see if they equal 54, and you check to see if they're prime numbers. So the prime factorization for 54 would be 2 times 3 times 3 times 3. Now, if you remember from chapter 4, our equations, I can write 3 times 3 times 3 as 3 to the third power. So if you want to make it a little easier on yourself, you can write it like that too. But either way is fine. They're both correct. Okay? So you can say 2 times 3 to the third power, or you can say 2 times 3 times 3 times 3. Now let's see what that would look like as a ladder diagram. So I start with 54. I'm noticing that 4 is an even number, so I know because of divisibility rules that I can divide it by 2. And 54 divided by 2 is 27. Sorry, that's not a very good 27. Let's see if we can fix it. Let's make that a little bit better. It's 27. And I know my math facts, so I know that 9 times 3 is 27, so I'm going to use a 3. Then I'm going to get a 9 here, because 27 divided by 3 is 9. You put the answer below. And then I know that 3 times 3 is 9, so 9 divided by 9 is 3. And then 3 divided by 3 is 1. So I've gotten to 1, so I'm finished. And my factors are 3 times 3 times 3 times 2, which is exactly the same as I got with my factor tree. And I don't like to write out all those 3 times 3's. So it's 2 times 3 to the third power. So there you go. There's both examples. Whichever one you like the best is the one that you can use. Just remember you want to check your answers. And you also need to make sure that your answers are prime numbers. So if I had like 2 times 6 times 3 or something silly like that, 6 is not a prime number. So that would be an incorrect answer. Okay, let's look at another example. Okay, here we have 132. Now I am looking at 132, and immediately what popped into my mind is I looked at these last two digits and I thought 32, that's a 4 math fact because 4 times 8 is 32. So that's where I'm going to start. 4 times 8. Oh, sorry, just kidding, haha, because it's 132. So I know that 132 is divisible by 4. And I can do the division kind of over here because I don't know exactly what the answer is. So I'm going to come over here and see. Okay, 4 times 3 is 12. So it's 33. So I'm going to say 4 times 33. And then 33 is 3 times 11. So I know my math facts, so I knew that one. And 3 and 11 are prime numbers because they don't have any other factors. And then 4 is an easy one. It's just 2 times 2. So my answer is 2 times 2 times 3 times 11. And I can check that. 2 times 2 is 4. 4 times 3 is 12. And 12 times 11 is 132. Okay, so I've got the right answer. And 2 times 2 times 3 times 11, those are all prime numbers. So I have broken down 132 to its prime factors. Let's do it with a ladder diagram. So I'm going to pick, because for the ladder diagram, you're only dividing by prime numbers. I'm going to pick 2 because I looked at the last digit here. It's even, so I know that I can divide it by 2. So that's what I'm going to do. And 132 divided by 2, I don't know what that is. So I'm going to come over here just real quick and find out. 2 times 6 is 12. And then, so it's 66. So I'm going to put 66 down here. And I think I'm going to divide 66 by 3 and get 22, which I can divide by 2 and get 11, which I can divide by 11, because 11 divided by 11 is 1. And that usually, by the way, just as a tip, this last step is where people run into trouble. They forget that you have to end up with a 1 down here before you're finished. And so you want to make sure that you take this number 11, divide it by 11, you get 1. And these are all prime factors, so I'm in good shape. And it matches. 2 times 2 times 3 times 11. And these are all prime numbers. 2, 2, 3, and 11 are all prime numbers. And I know that because I can use divisibility rules and see that they don't have any other factors besides 1 and themselves. 11, 2, 2, and 3 are pretty easy, but 11, it's not divisible by 2, it's not divisible by 3, therefore it's not divisible by 6, not divisible by 4, 5, or 10, or 9, so I'm in good shape. Okay? So if any of these examples did not make sense to you, it's time to stop and rewind a couple of them, because the next slide is going to be your homework. So stop, rewind, watch it again a few times, do the best that you can. I realize that this is a new skill, and so if you're having a hard time with it, of course we'll spend more time in class on it. But it's really not that hard. It's just different from what you guys are used to. So give it a chance. Don't breeze through. I've noticed some of you are just watching the video and you're not making sure that you understand. If this does not make 100% sense to you and you feel like you're at least at a 3, ready to tackle it and become a 4 or a 5, then you need to watch the examples a couple of times. Don't blow it off, okay? All right, the next slide's going to be your homework. Okay, your homework tonight is to break down 96 into its prime factors. You can use a prime factor tree or a ladder diagram. Good luck. See you tomorrow.